We often think we are far more intelligent than we actually are, especially when it comes to understanding the vastness of the universe. Just 14 billion years ago, the universe as we know it didn't exist, but the mystery of how it all began continues to captivate scientists and curious minds alike. The truth is, despite all of our advancements in technology and science, we still don't know exactly what happened before the Big Bang. Even more astonishing, our universe is still expanding. There's one burning question at the heart of everything. Why did the Big Bang happen? While we may not be able to directly observe the Big Bang itself due to our current technological limitations, something extraordinary has happened. Thanks to NASA and the groundbreaking James Webb Space Telescope (JWST), we've taken a monumental step forward. For the first time, we're able to glimpse deeper into the universe's past and possibly catch a glimpse of the Big Bang's aftermath. But just how powerful is this new technology, and what does it mean for the future of astronomy? Let's embark on an incredible journey to explore this state-of-the-art device, the James Webb Space Telescope, and uncover its potential to answer some of the universe's most profound questions. The Big Bang, what makes it so important? Before we dive into the specifics of the James Webb Space Telescope, it's important to understand why the Big Bang is such a key focus for scientists. The Big Bang theory is the leading explanation of how the universe began, and it's an idea that has fascinated scientists and the public for decades. In essence, the Big Bang suggests that about 13.7 billion years ago, everything we see in the universe, galaxies, stars, planets, even time itself, came from a singular point, incredibly dense and infinitely hot. Then, in a sudden burst of expansion, the universe grew exponentially in what is called cosmic inflation. This rapid expansion continued for billions of years, eventually slowing down to the rate at which our universe is still expanding today. This theory provides us with the best understanding of how the universe formed and how it continues to evolve. But there's still so much we don't know, especially when we try to look at the very beginning, when the universe was a tiny, hot, and dense singularity. Despite this, the Big Bang theory is widely accepted and provides the foundation for understanding the cosmos. However, we still face an immense challenge. We cannot directly observe the Big Bang as it occurred so long ago, and the light from that era has been stretched beyond visibility due to the expansion of the universe. But that's where the James Webb Space Telescope comes in. The power of the James Webb Space Telescope, JWST. The James Webb Space Telescope is not just a successor to the Hubble Space Telescope. It is a revolutionary instrument that is transforming our ability to study the universe. Unlike Hubble, which primarily observes invisible and ultraviolet light, JWST specializes in infrared observations. This ability to see in infrared allows it to peer through cosmic dust clouds, revealing objects and phenomena that have been hidden from previous telescopes. It can even look back in time to see events that occurred just a few 100 million years after the Big Bang, an era that was previously invisible to us. Launched in December 2021, JWST has already begun sending back images and data that challenge our understanding of the early universe. Its infrared capabilities give it the ability to capture light from the very first stars and galaxies, objects that formed within the first few 100 million years after the Big Bang. These observations are shedding new light on the formation of the universe and raising exciting new questions about how galaxies, stars, and even the first elements were created. The cosmic microwave background, a glimpse of the past. Before the advent of JWST, astronomers relied heavily on the cosmic microwave background (CMB) to study the Big Bang. The CMB is essentially the afterglow of the Big Bang, a faint radiation that has been traveling through space since the early universe. It provides us with a snapshot of the universe when it was just 380,000 years old, which is as close as we can get to observing the Big Bang directly. In fact, it was the discovery of the CMB in 1965 that provided the final confirmation of the Big Bang theory. Over time, scientists have used the CMB to learn about the universe's expansion and the fundamental properties of matter from the very beginning. However, the CMB only gives us part of the picture, and there's still so much we can't see with just this radiation. That's where JWST takes over, offering an unprecedented opportunity to look deeper into the past and see things we couldn't even dream of observing before. Thanks to its ability to detect infrared light, JWST allows us to look at the faintest, most distant galaxies, some of which formed just a few million years after the Big Bang. Why do scientists care about the Big Bang? The Big Bang is more than just a historical event, it's the key to understanding the entire universe. By studying the Big Bang, we can unlock mysteries about the origins of matter, energy, and even the fundamental laws of physics that govern our reality. For example, the early universe was a hot and dense place where the fundamental building blocks of matter, such as protons, neutrons, and electrons, came into existence. Over time, these building blocks combined to form atoms, stars, galaxies, and ultimately the vast universe we observe today. But understanding the Big Bang is more than just piecing together the past. It's also about answering big questions that affect our understanding of everything, from the formation of galaxies to the nature of dark matter and dark energy. These are some of the deepest questions in science, and JWST is providing new insights that could completely transform our view of the cosmos. A new era of discovery. What has JWST revealed? Since its launch, JWST has already made groundbreaking discoveries that are rewriting our understanding of the early universe. For instance, it has detected galaxies that are older, larger, and more massive than anything Hubble ever observed. Some of these galaxies may have formed just 180 million years after the Big Bang, which is far earlier than astronomers once thought possible. One of the most astonishing discoveries came from the galaxy Glass Z13, which appears to have formed just 50 million years after the Big Bang. Such early galaxies challenge our current models, which suggest that it would take hundreds of millions of years for galaxies to grow to such massive sizes. Additionally, JWST has observed massive galaxies, some that may even rival the size of our own Milky Way, during the first few hundred million years of the universe. This is completely unexpected, as current models predict that galaxies at that time should have been much smaller and less developed. These discoveries are forcing scientists to rethink everything we thought we knew about how galaxies form and evolve. What's next for JWST? As JWST continues to send back data, we can expect even more groundbreaking discoveries in the coming years. Scientists will use this telescope to study everything from the formation of stars to the hunt for distant exoplanets. JWST will also be instrumental in exploring the enigmatic nature of dark matter and dark energy, two of the universe's most elusive and mysterious components. One of the most exciting possibilities is that JWST will help us answer one of the biggest questions in cosmology: what exactly happened in the moments right after the Big Bang? With its ability to detect faint light from the earliest galaxies, JWST is helping us peer further back in time than ever before, bringing us closer to understanding the universe's origins. Conclusion: a new dawn for astronomy. The James Webb Space Telescope has already made history. With its unprecedented power and precision, it is unveiling the deepest mysteries of the universe, from the formation of the first stars to the birth of galaxies. The discoveries made by JWST are pushing the boundaries of our knowledge and challenging the very models we once held as truth. As we continue to explore the universe, JWST will remain at the forefront of discovery, helping us understand not only where we came from but also what lies beyond the stars. The answers it provides could reshape our understanding of the cosmos for generations to come. What incredible discoveries do you think JWST will make next? Let us know in the comments, and be sure to subscribe to stay up to date on the latest revelations from this extraordinary mission. The universe is calling, and we're only just beginning to answer.